All right, so here's a problem we'll do, and I'm looking at the series. The sum as n goes from 2 to infinity, 1 over n times natural log of n in the denominator. And I want to model this. Well, I'm going to say model a sub n, which is 1 over n times the natural log of n, with f of x equal 1 over x times the natural log of x. And I'd like to try the integral test, so I need to look at the function and say, is f of x continuous? I'm going to squeeze in over here on the interval 2 to infinity. Is f of x continuous, positive, and decreasing on this interval 2 to infinity? Yes. It's continuous since the denominator's never 0 on that interval. Is it positive? The natural log of, after natural log of 1, this is positive. Yes?
On the test ones, we need to write down why we know it's
If
increasing.
it's obvious, no. If it's not obvious, yes.
Would this be considered obvious?
This one is obvious. Okay. And then decreasing, and because they're both in the denominator, and because, see, that's would be in, as x gets bigger and bigger and bigger, x is getting, this part, ln of x is getting bigger and bigger, so the denominator, being that's in the denominator, the fraction's getting smaller. So we got that. Now, I'll try the integral test. So I'll find the integral from 2 to infinity of 1 over x times the natural log of x dx. I'm going to write this as the limit as t approaches infinity, the integral from 2 to t of, I'm going to split this up, ln x to the minus 1, maybe I could have just left it 1 over ln x, times 1 over x dx. I'm trying to give you a hint right there. What am I thinking about? U substitution. U would be what? ln x. What's the derivative of ln x? 1 over x. Here's my du. Here's the u. So, and I'll change my limits of integration this time. A lot of times I do not change them. Let's see, the limit as t approaches infinity, if u equals ln x, and this is a value for x, when x is 2, u equals the natural log of 2. And when x is t, u equals the natural log of t. So this would be 1 over u du. What is the antiderivative of 1 over u du? ln u. So this is the limit as t approaches infinity of ln u. We're going from the natural log of 2 to the natural log of t. So we'll plug in natural log of t first. The limit as t approaches infinity of the natural log of t minus the natural log of 2. And if you like, you put absolute, well, you know, it should be the natural log of the absolute value of u, but U is always positive at this point. All right, what about this? As t approaches infinity. This might be a little hard to think about. This is going to infinity. It's going very slowly, but it's going to infinity. Infinity minus the natural log of 2, that's infinity. So the integral diverges. So what about the series? Diverges. And I kind of would like you to write this. Tell me what test you're using. By the integral test, although it should be obvious at this point in this problem. But somewhere give that in your solution. By the integral test, the series, the sum as n goes from 2 to infinity of 1 over n times the natural log of n diverges. Make sure when you work these problems on Thursday night that you give this conclusion. You know, don't just leave it right here and it's equals infinity. The integral is diverging, so then you expect us to finish it off. Finish the argument right there.